All right, thanks for getting the doors. All right, we're ready to start. Hey everybody, I'm Frank Lesniak and I'm joined with Danny Stutz. We'll introduce ourselves in a second, but if you're here to learn about some data science stuff in PowerShell, you're in the right place. What I think we're most excited for about this talk, we're going to go through a specific use case and that's interesting in and of itself, but I just think it's kind of neat to do data science stuff in PowerShell. It's not a common use case for PowerShell. It's, typically when you think data science, people will refer you to Python or maybe MATLAB if you're more of an academic. So that's, I think, if you take away nothing else, that's a good takeaway from this session. Just a little bit about me. I've been in consulting almost 20 years. I've been working with PowerShell since it came out, although I don't really consider myself very good at PowerShell. For example, I've never written a module. Don't spread that too widely, but that's true. I've got some contact information up on the slide. If you want to scan a QR code and connect, I'd love to connect with you all. And maybe one more fun fact before I pass the mic to Danny. I've got a talk in 2 weeks at MMS on building a passive aircraft radar. So, kind of a renaissance man in some ways with technology stuff. Like to have fun with it. All right, Danny.
Yeah, no, thanks, Frank. So, hey, everyone, Danny Stutz. Also similar to Frank, I work with Frank. I've been in IT consulting for about 5 years. I'm mainly working like the M365, Entra, Azure security space, as well as, just pretty much automating anything with migrations and stuff. So, yeah, one fun fact about me, if you have a mechanical keyboard and you kind of adapted to it during COVID like I did, catch me outside after. We can talk about mechanical keyboards. It's like one of my favorite things that I own and kind of one of my favorite hobbies that I've been on. So, yeah.
Right on. And Danny, I'll let you talk about sponsors.
Yeah, just wanted to give a quick shout out to all our sponsors. I know James had mentioned this yesterday, but it really wouldn't be possible to have these types of events without the sponsors. So I just wanted to flash up the thank you to our sponsors really quick. So
Yep. And we didn't really mention it, but we both work for West Monroe. We're really appreciative that we're here. We spent work time working on this conference talk today. We got a bunch of West Monroe swag up front if anybody wants to grab a pen or a squishy ball to throw at somebody later. There's all kinds of good stuff up here. Agenda?
Awesome. Yeah, and so for the agenda today, really, so we'll start off, going through some of the survey results. So we'll collect the survey results, and then during the demo, we'll actually go through the live analysis of all the responses. So kind of just introduce that. We'll go through kind of the context, level set on, what kind of brought us here, what was the, use cases that we had seen for it, and, why do we, develop this process. Then we'll get into some more of the data science-y type things around, scrubbing the actual data and, anonymizing it. How can we, achieve that? And then we'll go into, some of the more nitty-gritty things around, the OpenAI embeddings. How do we cluster, these embeddings, and then also, the centroid around k-means clustering. This will all kind of make sense as we, talk through it and provide you a little more context after, but, that's kind of our high-level agenda for now. We'll go through getting the topic, and then we'll do a quick code review and a demo following that.
Yeah, if this doesn't make sense, that's expected. So just stick with us. It will.
So as the slide says, survey says, we'll leave this up for about a minute or so. If you haven't already taken the survey, we'd really appreciate it. We'll use the results for live analysis, and feel like most of you have already done it already, so appreciate that. But just want to leave this up for 30 seconds or so, just so everyone gets the opportunity to scan that.
I'm going to cut you off. We're not going to take 30 seconds.
Yeah.
Hopefully you all have scanned this by now. If not, please do. And you can fill out the survey while we're talking. That's totally fine. Okay, so I'm going to take the mic here and talk about what it is we're trying to solve here. To be honest, I started working on this about a year ago. Not 4 years straight, but about a year ago I started working on analyzing text data. And it's not easy. Does anybody have any thoughts on why analyzing text data may be difficult? There's a lot of reasons. Shout it out if you do. We've got stickers up here. You'll see who we got a sticker of here in a moment. But typos, yeah. Thank you. Dialect differences. That's right. Yeah. So Danny and I could be saying the same thing effectively, but because he grew up from Minnesota, I grew up in the Chicago area, we might phrase things slightly differently, even though it's the same idea. Yeah, use of acronyms. Yep, that's a big one. We will talk about that a bit. Differences in languages. Yeah, English versus Spanish or whatever. Yep. Memes like meme words. Yeah, meme words or leet speak. Yep. Any others? Different writing method. Handwriting, you mean?
No, like Arabic versus
Okay, different styles like Roman numerals versus regular numbers is what you're saying, right? Yeah, gotcha. Okay, I'm going to click us through. I think we got to most of these actually. Yeah, text data is inherently unstructured. It's not something you can directly compare, at least not in the way that you might want to. Inconsistent from person to person. We covered a lot of these, right? Data privacy is maybe one we didn't talk about, and then context is another one. We'll come back to context. Without context, it might be hard to understand or interpret an answer to something. But just because it's difficult doesn't mean we don't need to do it. Some examples of reasons you might need to do some text analysis are survey responses. That's certainly what got me started on this initially, and what I pulled Danny in to help me with. If you work in IT, you might need to analyze service desk tickets. What was the nature of the ticket? How pissed off is the person? That sort of thing. If you're out in the product space, you might need to look at restaurant or product reviews. Or maybe you want to go to a restaurant. It might be helpful to analyze what's out there in terms of those reviews. And I'm sure there's other use cases too that Danny and I haven't even thought of. I always think it's a good thought exercise when you're going to automate something to think about how you might do it manually, right? So this is an example of me trying to think through, I guess, like some manual curation of some of the some survey results. This is all contrived, but you can see how I might have looked at the survey response and translated that into more of a summary. And because I'm doing the translation, I could standardize the way I'm translating it and maybe group things together in sort of a manual way. It's not perfect, and this is an automation conference, so we don't like doing things manually. Now, with that being said, we gave a little preview of this. I wanted to just spend a second on what exactly are we trying to solve for in the demonstration that we're going to show today. And really, the main use case is comments on a survey. So you all have hopefully filled out the survey that we've flashed up with the QR code. We want to be able to take those responses and not read hundreds of them. I mean, I'm sure there's not hundreds in this case, but if there's 500 survey responses, we don't want to spend hours or days looking through those and trying to grab all the insights out of them. We want to kind of bucketize those and then surface the key insights. That's really the main thing we're trying to solve for today. But you can apply the same kind of logic to product reviews or any other free text responses. We did a dry run of this at West Monroe, and somebody commented, aren't these all really the same effective problem? And yeah, they are, kind of. It's all free-form text data, right? Question, response kind of stuff. Going back to context for a second, this is really important. And we've got examples on the slide that show this, but there's a pretty big difference between the same response, without any context and then with some different context added. So just saying twice a week without any context, okay, who knows what that means, right? Versus how often do you exercise? Twice a week. That's sort of a middling, that's not a bad response. Somebody's getting exercise, that's probably pretty good, but maybe they should be exercising more, right? You might kind of have that sort of reaction to reading that. Versus how often you want to quit your job? Twice a week. That's really bad, right? That's a very different response. So context can be very important, but there are some gotchas to that too, which we'll talk about later. And then talking about data scrubbing and anonymization, when we think about how we're going to be doing this analysis, and I'm jumping ahead a little bit to solutioning here, but it's important to talk about this here. We're going to be using some large language model APIs, specifically with OpenAI, and there's sort of two different flavors of that. There's Azure OpenAI. You get a dedicated instance, right? So if you haven't looked into that, basically there's a duplicate of the OpenAI infrastructure made for you that you can access privately. So anything you submit doesn't get added to the language model. It doesn't become public data. So that's good. There's not really any privacy concerns there. The only negative I can come up with that, other than maybe price or cost, is that sometimes the model availability might lag slightly. Now, for the things we're using today, that actually doesn't apply. Today in 2024, the models were the same. So that's a moot point today, but that could be an issue depending on when you go to do this stuff. On the other hand, the public OpenAI APIs, you don't really have an expectation of privacy there, at least in my opinion. The data you're submitted can be used for training the model, that is. So effectively, I would not put anything confidential there. But you do get access to the freshest, best stuff in theory. So because we're using OpenAI APIs, the public ones for this talk, we need a way to scrub the data. And I think if you're like Portly PowerShell guy here, by the way, this is our sticker. You'll see Portly PowerShell guy appearing several times in our talk. He points out, hey, you wouldn't have to do this if you use the Azure OpenAI service, and he's correct. The honest truth for why we're not using that is because it didn't exist when I originally started working on this. So it didn't make sense for us to pivot, just based on the amount of time we had to prep for this talk. but it's a good option for sure. And then, we talked about acronyms earlier. Depending on what you're doing, jargon can also be an issue. And this quote actually is representative of a real response on a employee engagement survey at West Monroe. This means something to Danny and I, but you all probably have no clue what this means, and that's expected. So we'd want to standardize that language or transform that language in a way that hopefully it means something more to the large language model. At least that's my theory around it. Really what this is saying is everybody on Danny and my team is great, especially the consultants, the senior consultants, and the managers. That's basically what that's saying in regular English. Without going too much further, we want to throw a disclaimer here that Danny and I are not data scientists. We don't have an educational or practitioner background other than preparing for this talk. So if any of you are data scientists, you can probably run circles around us and accept our apologies in advance. We're going to do our best here. Okay, and then I've got a couple more before I hand the mic back to Danny. So embeddings. This is going to be the first data science-y thing we do. Embeddings are like the slide says, they're like GPS coordinates. Think of it as you've got a block of text, and embeddings tells the large language model what that text represents. It's the best way I can describe it. So GPS coordinates, you've got 3 dimensions, x, y, plus altitude. People tend to forget about altitude. But you've got those 3 dimensions with GPS coordinates. Instead of those 3 dimensions with a large language model, in this case, we have 3,072 dimensions, which is impossible to visualize or show in any kind of way. But there's that many dimensions or vectors to the embeddings model that comes out. So you put in text, you get out numbers, if that makes sense, really simply. Just a note, we are embedding text in this example, but you can also embed images, and there's some use cases for that. We're not going to get into that, but I wanted to mention it in case you look into this yourselves. And then, if I kind of took a step back when we were putting these slides together, and the whole talk is really predicated on this idea that similar text or similar ideas, themes, all that stuff have similar embeddings. And I have no way to prove that because the embeddings model used by OpenAI is not public information. So I'm sure somebody at OpenAI has a spec on this, and it's known to them, but it's not public information. There's no way to really reverse engineer it. So we can't prove this, but it's a data science construct, I guess, or data science principle that we are going to assume is true for this talk. So thanks to the data scientists for establishing that. We're going to assume that similar text is similar coordinates. And then one more thing on embeddings. They do cost money, not a lot of money. The model we're using costs 13 cents for every million tokens. And each word is typically 2 to 4 tokens. So you get a lot of bang for your buck here. But nonetheless, it's not free. It does take money to generate them. It also takes time. We're going to be talking to an API. So we're making an API call for every bit of text that comes in. And then we're also storing these on disk, which takes disk space. And you'll see when I show some CSVs, the pronounced size and disk difference. And there might be more efficient ways to do that, storing it on a Cosmos database, for example. But we're just doing a PowerShell demo here on disk, so keeping it a little more simple. I keep saying there's one more thing. There's one more thing. OpenAI is not the only game in town. Yeah, there are other embeddings APIs available, and depending on the timing, it seems like there's different ones favored by data scientists. Like when Danny and I talked to our data science team, they were recommending some alternatives actually over OpenAI. But since then, OpenAI came out with their version 3 model for embeddings, and that seems to be superior. So depending on the time you do this, there might be other alternatives out there that you might want to consider. Okay, over to Danny.
Awesome. Yeah, thanks, Frank. So as Frank was talking about, embeddings, they're effectively coordinates. They're GPS coordinates, right? There's a numerical representation for the text that we're analyzing, right? And to effectively group these embeddings together, or these the text together, right? We use a method called k-means clustering. So k-means clustering is really just an algorithm that will basically iterate through the different data points. What you see right here on this visual kind of GIF is actually a nice representation of how it works, right? So the triangles are the centroid. We'll get into that in a second here. But what's really happening here is, right, what the k-means clustering does is it starts at kind of a random data point for where it thinks the categories are, right? And as it kind of, places these categories around, or these, centroids, it will move them around such that it's in the best position, or what it thinks is the best position for, a cluster of data, right? And so this is basically how, the different comments and things that are related to each other are grouped together, right? Is by using k-means clustering to really iterate through each data point and, group it together, based on how far it is from a specific cluster or a centroid. So kind of moving on here. So there are many other, algorithms and methods to actually, group and categorize this data, or, analyze it, right? The one that we heard most commonly from the data science team at West Monroe was DB-scan, so density-based spatial clustering of applications with noise. There's a few other here that are listed, but that's really all this is to say is that k-means clustering isn't the means to an end, right? There's other methods to cluster this data together. Yep. As Poorly PowerShell guy says, why didn't we just, use DB-scan or write our own method in C# or PowerShell? And well, to be honest, the main reason that we use k-means clustering was for convenience. There are, there's tons of different, models and, algorithms that are available in like Python, but in PowerShell, right, we found it easiest to, use k-means clustering just because it's available, within PowerShell, pretty available. Not necessarily PowerShell, it's technically .NET, but, for the sake of an example here, that's really why we used it. So going back to what I was saying earlier around the centroid. So basically, once we've, created the clusters and assigned, where the centroid is going to be, that is really effectively the category. So each cluster has, a specific coordinate known as the centroid, and all data points that are grouped around it are, belong to that centroid or to that category, right? So it does a little bit of, basically that's what k-means does, is it measures the distance from each of these data points to each of the clusters and sees, how close is it in relatedness, right? So say, for example, like this data point here, right, is super small, but it's, it seems like it's closest to, it could be belonging to the purple cluster, it could be belonging to the orange one. But it's just based on the Euclidean distance, it's a linear algebra term, between the data point and the centroid itself, and it determined that it's actually closer to this category than the others, which is why I grouped it there.
Danny, before you move on, I want to take a second. You can see there's 5 clusters in this graphic. In terms of the, if you see the different color codings, but if you look at where the points kind of converge and come together, I mean, it looks like there should be maybe more than I see 5 key groupings, but then also a large disbursement of other data points. So I think one thing that I just want to mention here about k-means clustering is you have to tell the algorithm how many clusters you want. So you have to sort of know something about the data set, or you have to iterate through different clustering activities to find the best one. And in this one, it almost looks like they should have picked a different number to me.
Exactly. Yeah, and so kind of moving along here to talking more about the centroid. So really, yeah, once we basically have, the coordinates of the centroid, there should be an item that is closest to that centroid. What we call that is the most representative item of that cluster or that topic, right? So in theory, really, this, this closest item should be the most representative, as in it should, kind of have the idea around the category, solidified, and it should be, most related to it. Oops.
That goes there.
Yeah. Put that aside. As Poorly PowerShell guy says, you might be more confident if you listen to DB-scan, and really by that is what he's saying here is, if we use DB-scan will automatically basically calculate the ideal number of clusters, as you run it. And so that's, one of the advantages of using another algorithm to cluster the data is, some have different features, or, how it actually, the implementation of the algorithm actually works. Kind of moving on to this more. So you can do, we can, pull say, for example, the top 5 most representative items in the cluster. This would be the top 5, for example, comments that are most related to the topic, that the cluster is centered around.
Yeah,
So,
the advantage of that is you remove maybe some bias, right? If you got that most central item, that should theoretically be the best comment that represents the cluster, but it could also have some subtext in there or some bias inherent in it. So sometimes it's beneficial to think about more than just that one item, and you can grab 5 items, for example.
definitely.
Yep.
Back over to
Okay,
you, Frank.
and it's back over to me. All right, right on. So far we've effectively grouped similar ideas together, and we've found the most representative idea or ideas in that group, right, or cluster. But we still haven't programmatically surfaced what the topic is, which is what we're trying to do. We're trying to get that key insight out of each comment, right, or each category. So the last thing we need to do is take that most representative comment or group of comments and ask ChatGPT for help by literally asking it, what is the theme of this comment or comments? And we'll show you the prompt we use for that, by the way. It's not perfect, but it does work. So we'll get into that. So just to kind of summarize, here's the end-to-end process. First, we want to add context to the data if necessary. So if you look at your data set and the answers to the questions don't make sense on their own, you might want to essentially do a string concatenation and add the question in there. Hey, on a survey, I asked the following question, and the person gave the following response, for example. So that's adding context. Removing any company-specific jargon or identifiable information. So a really simple example would be replacing West Monroe with Acme Company or something, if we were submitting West Monroe data to the public API. Pulling down the embeddings for the data set from OpenAI. Those are those coordinates we were talking about. And then we would use that local embeddings file, the CSV stored on disk, and perform k-means clustering on it, maybe iteratively if we want to change the number of clusters. So that's an option too. Finally, as part of that process, we would identify the most representative data points and submit those to ChatGPT to literally define the categories for each cluster. And then finally output that information to a kind of a CSV that gives us the insights we're looking for. So we'll show you all that. That's the end-to-end process. So with that, we're going to start code review. We do have a QR code if anybody wants to access our GitHub repo. We put this live today. So if it's easier for you to follow online, feel free to scan that and pull up the repo. I'll just give you 5 seconds, and I'm going to click ahead and start the code review. I think, Danny, you're up first, right?
Yep.
Okay. All right.
Yeah, so as Frank was talking about, context is really important when we're reaching out to AI and OpenAI and basically asking it a series of questions, right?
Well, sometimes.
sometimes, right? So basically, what we've done, at least with this initial script, is it adds context to the data set in terms of it'll transform some of the fields, for example, the question and the comment into a new field, additional context, right? So we access, we dynamically access the CSV column names through the script basically to pull that information out. And then we'll take that in and basically concatenate it into this, text box right here, right? So this was specifically written for, an employee engagement survey. You can provide it with whatever context you would want, but basically it's going to take in the question that we have inside of the CSV and then also the comment and put it in this format so that, OpenAI or whatever LLM can better understand, the prompt that's being given. We threw this slide up here because mainly there were a lot of things we did along the way in PowerShell that we thought were very cool. However, unfortunately we only have 45 minutes for this talk, so we're not going to go over all of them. But if you want to talk about any of this, after our talk, then definitely feel free to, talk to us outside, and we'll definitely
I think we're doing a lightning demo on some of this, so we'll try and go through it as quickly as we can.
Yeah. Moving on here to the anonymizer or the remover jargon script. Basically, this script is a simple way to find and replace, specific data inside of, a CSV file. It's nothing honestly super complicated, right? So, for example, we have West Monroe becomes Acme Company, as Frank said, and here's kind of an example of, our, case-sensitive words replacement. As you can see, it's just really simply like find and replace, effectively, going through and iterating through the CSV and replacing it with, the specific word or the full word that you want to replace it with. Right?
Yeah, notice most of this is jargon, right, or dejargonization. It's not as much. There's obviously some removal of West Monroe and et cetera, but mostly we're getting rid of jargon here.
Exactly. Same thing for case insensitive words, right? So that's something to know that's a little interesting, right? Is when you're finding and replacing words, right? You have to be very specific about the casing of the word that you're trying to find, right? So that if for example, you're trying to find ERG, if it's tagged at the end of a word, right, like ERG is at the end of a word, you don't want to replace that, right? So it's important to have, capitalization and sensitivity for that.
Yeah, just going back for 1 second, this shared services example shows that, right?
Exactly.
Like for that one, we'd want to use case-sensitive replacement because we would not want compass team to get messed up as you see on the example.
Exactly.
Oh, that's what I mean. Okay, yeah. So we've done some basic data scrubbing and context establishment. That's all pretty simple PowerShell. Getting into some more simple PowerShell, we're going to go ahead and get the embeddings using OpenAI. This is a simple API call. If you've done any work with APIs in PowerShell, there's not much going on here. Basically, we're getting an authentication header, and we're building a JSON request body. This is all pretty well documented, both in official OpenAI documentation and in various blogs on the internet. So you won't have any trouble doing this. I guess the thing to point out is the input property in the JSON request is that's the thing we're getting the embeddings for. And we set a temperature, which is basically, I guess, how stoned is ChatGPT? How stoned do we want ChatGPT to be? 0 meaning totally sober, 1 meaning it's been using some illegal substances. But then we do invoke Rust method, get the embeddings. It's pretty straightforward from there. While we're showing the model as a parameter, we actually have it hard-coded in sort of a wrapper script to make this a little more straightforward to write code for. So if you go look at the code, you'll see that. And then as Portly PowerShell guy points out, we might be in trouble calling an internet API from a conference, but one more kind of piece of goodie is we've set up some automatic retries with error handlings, basically with recursion. We have a function that will basically check for both terminating and non-terminating errors on anything that function's doing, as well as essentially an empty result. And if it detects any of those conditions, it will recall itself up to a certain number of times. So I wish I had wood to knock on, but knock on wood, we hopefully are good for the demo here today. A couple other goodies that we built in is a check for missing PowerShell modules, and the script will provide a helpful installation command. To be honest with you, I intend to provide this capability to some folks in our HR team. And I don't want to become, their support resource exactly. So I tried to make it as user-friendly as I could. We're also checking to make sure modules are up to date. So there's that too. But as Portly PowerShell guy points out, you don't need modules to call an API. That is true. However, we are also using the secret management module to securely store and retrieve the OpenAI API key from Azure Key Vault. So again, if you've used this, it's not super novel, but for Danny and I, it was a good exercise to work through, and you'll see the code for that in our scripts. So then we get into doing the k-means clustering, and this is the part, to be honest with you, that I think I'm most excited about and is maybe the most interesting from a pure PowerShell perspective. We're going to be using the Accord.NET NuGet package. NuGet packages are kind of like PowerShell in a way. They're kind of like modules in a way. You can pull them down from the internet and use them. And PowerShell has some capability to do this, but it's a little difficult. I'll get into that in a second, but Portly PowerShell guy wants to point out that Accord.NET is end of life, yet we continue to use it. Well, that's true. There is a Microsoft machine learning NuGet library that is actively maintained and probably a better option for modern development, I would agree. However, we decided to stick with Accord.NET because, in addition to the 2 reasons on the slide, first of all, that was what I was already using when I wrote some code a year ago. But we decided to stick with it because it's backward compatible with good old .NET Framework 4.x, so like 4.5, et cetera, as well as .NET Standard 2.0. So for us, what that means is we can use this NuGet package with both Windows PowerShell 5.1. Think of that HR person use case, right? I don't want to make them install PowerShell 7, right? So they can use PowerShell on their Windows box, as well as PowerShell 7, the new stuff. So it works with both. So that's kind of convenient. And there are a lot of goodies in this script. We split strings without using regex. So I have a function wrapper that does a split string on literal string, just because I'm lazy and I suck at regex. so Portly PowerShell guy feels bad for me. And then this is, I think, the coolest part here is we've got some functions that make pulling down NuGet packages a lot easier. So first of all, we check to make sure NuGet.org is registered as a package provider. This is like the PowerShell gallery, to draw an analogy, right? PowerShell gallery is registered by default in PowerShell, but NuGet.org is not registered by default. So you have to do something to register it. Then we check to see if a NuGet package is quote installed or basically downloaded and staged, downloaded and unzipped. And it gives you a warning message if it isn't with a command to go ahead and install it. And then maybe if any of you have worked with NuGet packages, they're a little hairy to work with because they get staged into a sort of a folder in your user profile, which varies cross-platform. And in addition to that, for all the different versions of .NET that NuGet package supports, there's going to be subfolders and then subfolders for the version, et cetera. And just getting the path to the DLL that you're going to load is a little tricky. So we wrote some wrapper functions that make that easy, and I think that's kind of neat. So once you have the DLL path, we simply load the DLL using add type. There's a couple other ways to do this too, but that's what we used. And then I'll show you how we did the k-means clustering in a second, but like I said, you need to have the number of clusters determined before you do the k-means clustering. So you see the to-do there for dynamically setting the number of clusters. We'll get into that in a second, but for now, what we're at least doing, this is an available parameter, so if you want to specify the number of clusters, you can definitely do that when you call the script, but if you omit that parameter, what the script will do is basically get the square root of the number of items, round it up, and use that number. So if there's 500 responses, I think the square root comes out to 23, basically. So that's what it would use, just as a best guess. And depending on your data set, that could be an okay guess or maybe a terrible guess. It really just depends. So you have to look at the results and decide. Going back to the to-do item, there are algorithms to sort of optimize the number of clusters. Specifically, the elbow method is probably the best known of those. Danny and I are not data scientists, and while we've looked into this and broadly understand it, we haven't implemented it yet. So hopefully we will do that at some point, especially if there's interest in this. But just note that that's not quite implemented yet. And then, I guess this basically shows you how we do the k-means clustering. I think the syntax is very weird, but I guess the key point here, if you don't already know this, is because we've loaded the .NET DLL into memory, we can access those objects afforded by that DLL just like we do any other object. And actually, I sort of glossed over this, but we load 4 DLLs, I think, for all the different Accord packages we need. But this is the syntax to do the k-means clustering. So we load the type and tell it how many clusters. We tell it to learn the embeddings, and then we tell it to decide the embeddings, which gives us the basically the assignment of a cluster to each item on our list. So if there's 500 items, we'd get an array that lists the cluster number that each item is assigned to as a result of that. And then we can dig in and get information on the centroid, et cetera. You'll see that in the code if you look at it. Okay, I guess, we've got a small thing related to the cluster here. So the next thing we do after we get the centroid information and we know which cluster each item is assigned to, we need to get the Euclidean distance. Danny mentioned this earlier. But without getting into the details too much, it's basically the distance between 2 points on a map. Because what we want to do is sort the clustered items. So if everything in cluster number 1, right, we want to sort those by distance to the centroid so that the closest items to the centroid are first, and then we can kind of use those as our most representative items. Hopefully that makes sense. The final script in our process is to get the topic, right? We talked about that, right? So this is going to be, again, a simple API call because we're going to hit the OpenAI chat API. So it looks like this. We, again, get a authorization header, authorization header, and we build our messages. It's a little different because you have to tell ChatGPT what its role is. We tell it it's a large language model by OpenAI, but you can get kind of silly with this and tell it, I don't know, it's a wizard in a Harry Potter book or something. You can get really silly with what role you give ChatGPT. And then we provide it the content on the bottom as the user, which is basically the prompt. I'll show you the prompt in a second. And then we submit that using invoke REST methods. So not particularly novel, typical API stuff. One thing that made this a lot simpler is we don't need a conversation with OpenAI. Probably many of you have used ChatGPT, and you can kind of go back and forth and ask questions and have a conversation. We don't need to do that. We're going to ask one question and get one answer. So that does make this exchange a lot easier and simplifies our code quite a bit. So this is an example prompt. This isn't perfect, and something that could be tweaked. But this would work. So this is what we do. So we say in as few words as possible. Certainly no more than 1 to 3 words because ChatGPT is a line stepper and will tell me, even if I say, If I say 1 to 3 words, sometimes it tells me 5. Sometimes I don't understand this this product, but that's what it does. Describe the topic, main idea, or theme of the following 5 texts treated as a set. Each text is separated by 3 forward slashes. And then we list them out with 3 forward slashes separating them. Or if there's 3 forward slashes in the text data, we've got an algorithm to dynamically select something else. And then here we do the automatic retry logic again. That automatic recursion I was talking about, that's here as well. So if we get a terminating or non-terminating error or a non-result, it will detect that as an error and retry. So hopefully, knock on wood, internet gods are with us, et cetera, and we will not get screwed up. So with that, we're into the demo here, Danny. Okay, perfect. So I'm going to Alt-Tab over. So Danny has sent me the Microsoft Forms results. I'm going to go ahead and download these, and I'm going to move them into a working folder here. It looks like we got 17 responses, including Danny and myself earlier. So I'm going to paste that file here. I'm going to grab the name of the file. Okay. Go over to VS Code. I just have a quick little demo script here to make this a little easier. So I'm just going to change the name of the file and save that. And the first thing we're going to do is, I'm going to kill this. Oops, I did not mean to do that, sorry. Sorry, folks, this is me not having a real mouse. There we go, okay. All right.
While Frank gets that set up, everyone gets a sticker. Thank you all for coming. So
yeah, thanks. Yeah, we printed some Portly PowerShell guy stickers. All right. So the first thing we're going to do, I mentioned this briefly, but it's we got the results from Microsoft Forms. They're in Excel format, and if anybody's actually, I should just open that up and show you what the format looks like. The format of this file is each person is on a line, and their answers to the questions are in columns, which is fine. There's nothing wrong with that format. However, it's not the format that our script expects. The script expects question, answer. So each question and answer should be on its own line for our script to work. That's just how it's designed, because that's how the data set I was originally working with was. So we need to convert this and flip it around. So we're going to go ahead and do that. So that's what this initial code here does. So I'm going to go ahead and run that. Okay, and I'll show you what that looks like as we flipped it on its head. So open that Excel real quick here. So you can see person 1, which I think was me, based on the timing, wrote 4 answers and to 4 different questions, and those are each on their own line. So you can see how we've sort of flipped that or done kind of a transpose on that. So now it's in the right format for us to proceed. Danny mentioned this earlier, but I just wanted to mention that the column names are not hard coded. You can specify the column names as parameters. So don't feel like you need to open your data set and rename columns and stuff. That's not strictly necessary. So we're going to go and run the next bit here. Oh, sorry, one more thing. We're going to skip adding context to the data set. We asked more complicated questions that weren't just simple yes/no questions. So I don't think there's going to be kind of simple answers that require context to be added. And Danny and I actually found that when you add context and it's not necessary to do so, it actually messes up the clustering a little bit. You start getting items that are not really that related getting clustered together, which we don't want. So I'm going to skip that here. We're also going to skip the anonymization and dejargonization, if that's even a word, because we don't need to. And you guys might have used jargon. That's okay. We're all PowerShell friends here together, and I don't really care for the purpose of this demo. So the next thing we're going to do is get those embeddings or those coordinates. So I'm going to go ahead and run this. And this should be pretty silent, but you can see I'm giving it information about my Entra ID tenant and my subscription and my key vault and my secret. And if I would have ran this for the first time, I ran it earlier and probably should have restarted VS Code. It'll prompt my browser and make me authenticate to Azure. But in this case, I'm already authenticated. I did MFA and all that, and we're rocking and rolling. So that just finished up, and let me show you what that looks like. First of all, I know it's a little small, but you probably can see that the file size has jumped quite a bit because we wrote all of those coordinates or numbers to a CSV. So we've basically made them strings, which is not a very efficient way to store this data. Go use Cosmos DB if you're doing this at scale. But let me just show you what this looks like if I open it in Excel. It's a little comical because there's so many numbers that it's word wrapped or line wrapped in Excel. So you can't really even view this. And I think it was 3,072 of these numbers associated with each piece of text. So it's a pretty meaty transformation we just did, I guess. So not super useful to us humans, but will be very useful to do the k-means clustering algorithm. So next, we're going to go ahead and cluster these responses. I have not specified a number of clusters here, so it's going to use the square root of, what do we have, 17 responses? Okay, so 17 times 4, there's 4 questions, and because we blew those out into their own line, so whatever the square root of that is what it's going to use. So I'm going to run that. And you see that didn't take very long. But this is not a big data set, and I'm on a lower powered computer. This is actually an ARM64 laptop, so it doesn't have a lot of horsepower. Not that ARM doesn't have horsepower, but this one is fanless, so it doesn't have much. And that didn't take very long. So it went ahead and did the clustering. The output here is not super user-friendly. It's going to be just basically numerical indices into each cluster. So this is telling me I have 9 clusters. So 9 must have been the square root of 17 times 4. Sorry, math is not my strong suit today. And it's saying that the most representative item for the first one is item number 8. So if I were to go back to the blown out CSV that I created initially, the 8th item is going to be the most representative. And then I've got the top 5 items for each cluster listed, as well as the full set as needed. So again, we got something we can go back and kind of cross-reference, but this isn't super user-friendly. So the next thing we're going to do is run the last script, which gets the topic, and also goes ahead and looks up those comments and pulls them into the output file. So we can view this a little bit more easily. So oops, I'm going to run that next. And this is going to be asking ChatGPT, hey, what's the topic of this data set? We actually have it asking for the topic for both the most representative item, the single item, as well as the set of 5 or so. And you'll see there's some interesting differences sometimes when you do that. So now we've got a separate file here, and I'm going to open that up. So again, I can kind of see, I still have those indices here and all that, and I can see how many items are in the set, but we've specifically blown out the alleged topic. So like here, look at this one. Remember I said no more than 1 to 3 words? Look how many words this is. Oh, I guess there was a blank item there. Sorry, that makes sense that it did that. Probably this is somebody who skipped question 2 because it was optional. So that's fair, I guess. But anyway, you'll see that it sometimes line steps, as I mentioned. So we get to see what the most representative item is for the cluster, and we get to see the topic for each of these. So just take a second and look at those. The first one is LLMs and coding evolution. That's cool. It's good networking. Improve productivity. We've got a blank here, so we'll skip that. Skill development, data-driven enhancement. Emoji usage, that's kind of a bad one, right? Like I wrote I'm speaking in smiley face, and it said emojis usage was the topic. It's a little silly. But that might be one where context would be helpful, because I'm speaking doesn't really mean anything unless you understand that I'm speaking at a conference. Strategic delay, slow down every Microsoft product group's roadmap by 12 months. That's interesting. How to get away from all the people. So I mentioned to some of you, please go ahead and insert some comical responses. So we're seeing a little of that. That's awesome. So then we asked ChatGPT for the topic for a larger number of items, the top 5 items if there were 5 items in the cluster, or fewer if there was fewer. So just trying to expand this column a little bit. Sorry, I'm working with my touchpad here. So we can see, first of all, let's compare column F to column H. And you can see they're slightly different, right? Here it's LLMs and coding evolution. Here it's PowerShell and AI integration. Here this is pretty similar, networking and learning versus networking event. That's pretty similar. Productivity improvement versus automation benefits, pretty similar. This is effectively an ignore item. Skill development versus learning and networking, pretty similar. Now you can see we're starting to get some clusters that are similar. So you might conclude if you're looking at this that there's too many clusters, and you should maybe run this again with fewer clusters. Data-driven enhancement versus AI enhancement, pretty similar to AI integration up here. So again, another reason we might have too many clusters. Public speaking, speaker. So yeah, I said group 2 people together there that both said speaker, and that makes more sense. Delayed productivity. There's 2. Yeah, lazy development. Yeah. So that's another one. And then solitude seeking. There's only 1 in this item, so this is gonna be the same. So that's kind of the output here. It's not perfect, but it does. This is something I can pick up and kind of put into a slide and show to management of, hey, here are the key themes for all of the survey responses we just did. And I think that's more interesting than me going through every single comment and maybe introducing my own bias in the ones I pick out to show. So I hope you agree that this is somewhat novel and interesting. I certainly think it is. Danny, did I miss anything?
No, I think that's really it. I mean, yeah, I mean, that was, no, I think you covered everything, Frank, honestly.
Okay.
Yeah, I think, I know, how many of you have been using ChatGPT to like generate your scripts, or at least generate some of it?
Okay. Yeah, that makes sense.
Right. So, I mean, I think, as LLMs continue to evolve and as, ChatGPT continues to evolve, we'll find more use cases for this, or especially within PowerShell, right? I think we're kind of just getting started in terms of like how far, this can go at least. But hopefully this was, an interesting use case around, some of the data analysis and some of the data, kind of categorization you can do at least within PowerShell, as opposed to using Python or anything like that. So.
Yeah. Python, boo. This is PowerShell. All right, any questions, guys? I know we're at time, but just want to give an opportunity for that. We're also going to stick around afterwards. But anything immediate that anybody wants to ask while we're here together? Okay. All right, last thing, please take the survey. And thank you all.